Question 911. Let y is equal to f of x be the solution to the differential equation dy over dx is equal to 2x minus y with initial condition f of 0 is equal to negative 2. What is the approximation for f of 2 obtained by using Euler's method with two steps of equal size starting at x equals 0? Okay, if the question is to approximate some function value using Euler's method, then we always start with the formula for Euler's method. The formula for Euler's method is given by yn is equal to yn minus 1 plus step size h times slope at the point xn minus 1 comma yn minus 1. Alright? So we're going to approximate f of 2 using Euler's method with two steps of equal size starting at x equals 0, right? So let me draw number line here. That's x number line. Here is 0. That's x 0. And we're approximating f of 2, right? When x is equal to 2. With the two steps of equal size, right? So two steps of equal size. So we have to approximate f of 1 first. This is our step size h, right? Which is equal to 1 in this problem, right? That's x1, that's x2. Now we have to find y1 first. So we're gonna let n is equal to 1. Then the formula is y1 is equal to y1 minus 1 is 0 plus step size h times slope f at the point x 0 comma y 0. Remember that the slope dy over dx at x 0 comma y 0. Okay, here y 0 is equal to negative 2, right? When x is equal to 0, y is equal to negative 2. So that's a negative 2 plus step size h is equal to 1, right? From here to here, that's 1, right? So 1 times slope dy over dx. It's right over here. Slope is 2x minus y, right? So at this point right here, the slope is 2 times 0 minus y0, which is negative 2. So that's going to be equal to negative 2 plus 1 times, this is 2, right? So that's going to be equal to 0, right? And this value right here is approximation for f of x1, which is equal to 1, right? Now let n is equal to 2. Then we will be able to write y2 is equal to y1 plus step size h times the slope x1 y1, right? y1, we found it right here. y1 was equal to 0, right? So that's 0 plus h, step size is 1, times that slope dy over dx at x1 comma y1, right? x1 is 1, y1 was 0, right? So slope is 2 times x, 2 times 1 minus y1 is 0. So that's going to be equal to 0 plus 1 times 2, that's 2, right? So our approximation of f of 2, which is equal to y2, right, is equal to 2. All right? Question 914. The table above gives the selected values of f prime, the derivative of function f. If f of 0 is equal to negative 1, what is the approximation for f of 0.4 if Euler's method is used with the two steps of equal size starting at x equals 0? Okay, we're going to start with the formula for Euler's method. That is yn is equal to yn minus 1 plus step size h times slope at the point xn minus 1, yn minus 1. That's our formula, right? We are starting at x equals 0 with two steps of equal size, right? So if we draw a number line, x, let's say here is a 0, and we are approximating f of 0.4, right? So let's say here is a 0.4. Two steps of equal size. So if this is x0, this must be x1, this must be x2, right? And this is going to be 0.2, midpoint of 0 and 0.4, right? Here, when x0 is equal to 0, y0 is equal to negative 1. When x0 is equal to 0, y0 is equal to negative 1, it's given. We are starting at this point right here, and our step size, h is equal to, what is it? H is x1 minus x0, or we can say x2 minus x1. That's 0.2, right? Now, let's find y1. y1 is approximation for f of x1, which is 0.2, right? So y1 is y0 plus h f of x0 comma y0, right? We can find this equation by substituting 1 for n, right? 1, 1, 1, 1. So far so good? So y1 is equal to y0, negative 1, plus step size h, 0.2, slope, this is our slope, right? dy over dx at the point x0, y0, or f prime of, since x0 is 0, f prime 0, right? When x is 0, f prime is negative 1. So slope is negative 1. So that's going to be equal to negative 1 minus 0.2. That's negative 1.2. Right? Now let's find y2. y2 is using the formula y1 plus h f x1 comma y1. Right? We can write this equation simply by substituting 2 for n, right? 2 for n, 2 for n, right? And this is approximation for f of 0.4, right? Because our x2 is 0.4, right? So that is equal to y1. We found it right here. That's negative 1.2. Negative 1.2 plus step size h is 0.2. And when x is at x1, which is 0.2, right? Our slope is 4, right? So our slope at x1, y1, that's 4, right? So that's going to be equal to negative 1.2 plus 0.8. So that's negative 1.2 plus 0.8, that's negative 0.4. That's our approximation for f of 0.4 using Euler's method, right? Question 917. Consider the differential equation dy over dx is equal to y times 2 plus x minus 1. Let y is equal to g of x be the particular solution to the differential equation with g of 1 is equal to negative 2. Use Euler's method starting at x equal 1 with the two steps of equal size to approximate g of negative 3. Okay, here is the formula for Euler's method. Yn is yn minus 1 plus h times f n minus 1 comma yn minus 1, right? H is the step size, f is the slope dy over dx at the point xn minus 1 comma yn minus 1, right? Here is the number line x. Okay, we are starting at x equal 1, right? So let's say here is 1. That's x is 0. And we are approximating g of -3 when x is equal to -3 using two steps of equal size, right? So that's going to be x2. Then our x1 is middle point of -3 and 1. That's -1, right? So that's going to be x1. Now our step size is x1 minus x0, right? So -1 minus 1, which is -2. Or x2 minus x1, -3 minus -1. That's -2, right? So our step size h is equal to -2, right? So let's find y1. y1 is approximation for x is equal to -1, right? So f of -1, that is y1 is equal to y0 plus h times f x0 comma y0. All right, y0 is the value of y when x0 is equal to 1. So that's going to be -2 here, right? So -2 plus h, -2. Slope is right here, right? That's going to be y times 2 plus x. So what is y? -2, right? y0 is -2 plus, times 2 plus x. X is 1, 1 minus 1. So that's going to be -2 minus 2. So this is a 3, right? So -6 minus 1. That's -2 minus 2 times -7. So plus 14. So that's going to be equal to 12, right? Now let's find the approximation of g of -3. Well, actually, this is g, right? Not f, right? So g of -3 is our y2 using the formula y1 plus h f x1 comma y1. So that is equal to, our y1 was 12. So 12 plus step size h is -2 times slope at x1 comma y1. So slope is y times y1, 12 times 2 plus x1. That's -1, right? So -1 minus 1, right? So that's 12 minus 2. This is plus 1. So 12 times 1, that's a 12. So 12 minus 1, that's 11, right? So that's going to be 12 minus 22. That's -10, right? So our approximation for g of -3 using Euler's method is -10, all right? Question 918. Let y is equal to h of x be the particular solution to the differential equation with h of -1 is equal to. Find limit of this value. Okay, this is the limit as x approaches -1. We're going to substitute -1 for x. So that's going to be h of -1 minus -1 minus 3 over 2 times the -1 plus 1 squared. What denominator is actually equal to 0, right? h of -1, that's 2, right? So that is equal to 2 plus 1 minus 3. Numerator is also equal to 0, right? So that's indeterminate form. Then we're going to have to apply the L'Hopital's rule to solve this limit, right? Okay, I'm going to erase all of this expression. So this limit is equal to, by applying L'Hopital's rule, that's limit as x approaches -1, derivative of numerator, that's h prime of x minus 1. This is 4 times x plus 1 to the power of 1, right? Now we're gonna substitute -1 for x again. Here, if we substitute -1 here, denominator again it's a 0, right? What's h prime of -1? H prime of x, that's a derivative of function h, right? It's given right here. So when x is equal to -1, y is equal to 2, right? So we have to substitute 2. So h prime -1 is equal to 2 times 2 minus 1 minus 1. So that's 1, right? So this is 2 minus 1, which is equal to 1. So if we substitute -1 for x, that's going to be equal to h of -1, which is 1 minus 1. Here we have a 0. So again, it's a 0 over 0 indeterminate form again, right? So we're going to have to apply the L'Hopital's rule one more time. Let me erase this. So that limit is equal to limit as x approaches -1, derivative of numerator, that's going to be h double prime of x, right? Denominator is just equal to 4, right? Here, this is our first derivative, h prime of x. Then h double prime of x, which is the second derivative of this function, right? Is equal to, we're going to have to apply the product rule to find the derivative of this, because it's y times the 2 plus x, right? Derivative of y, that's dy dx, and we have 2 plus x, plus we have y, and derivative of 2 plus x, that's 1, right? And minus derivative of 1 is equal to 0, so that's just a 0. And this is h prime of -1 here, right? That was 1. So this is 1, 2 plus x is -1 plus y is equal to 2, right? So that is equal to, that's 2 minus 1, 1 plus 2, 3, right? So that is equal to h double prime of -1 over 4. And we found out h double prime of -1 is 3. So our final answer of this limit is 3 over 4. Okay?